Morning. Mr. Lesham is here. We are continuing with hyperbolas. This is our second lesson of hyperbolas. And if you notice, all our questions in function, just like last year, there's really two kinds of questions I can ask. Either I give you a function, y equal ax squared plus some kind of function, could be parabola, hyperbola, whatever, and then you need to sketch it. Or, as we're doing today, I'm giving you a sketch and you need to write down the function. So whenever you get a sketch, the first step is to think, okay, is it a linear graph? Is it linear? Is it quadratic, a parabola? Is it hyperbola, or is it an exponent? So by looking at this, what is that? Hyperbola, also maybe because of the hyperbola on the title, or you know the hyperbola. But you need to know the shape. You understand what I'm saying? You need to be able to recognize the shape. So when that comes to mind, this next thing that comes to mind is you need to figure out what's the general function of hyperbola. How do we write it? It's going to be y equal to a. So you need to start remembering it, because that is not going to be giving you as a formula on the text. A over x, but now we added plus b. Last year there was just a over x, but we did plus b, plus q. And then quickly remind ourselves what each one of these parameters, the x and the y are what we call variables. The x can take many values, okay, and the y can take many values, okay? But the a, p, and the q are parameters. They take a single value. They take a single value for a specific equation. So all we need to do really is find a, p, and q. Let's just remind ourselves to begin with what each one of them are. Let's start with q. What is q? Always vertical shift. Okay? It's not going to be the y-intercept. So I know a minute ago we spoke about linear graphs, and remember we said that q is the vertical shift and the y-intercept. Q is always the vertical shift, but it's not going to always be the y-intercept. Why is it not going to be the y-intercept? What is the y-intercept? The x is equal to what? 0. So let's just do that. I wasn't planning, but let's do that. Let's try and find the y-intercept in this case, where I don't know what a, p, and q, but let's just find it. So I'm going to write a over 0 plus p plus q. Okay, what is that? It's a over p plus q. And that's not the same as q. I still have that a over p. You understand? So the y-intercept is not q. But it is, the q is a vertical shift. Okay. So that's vertical shift. Let's write it down. Vertical shift. What about p? Okay, shall we pause here, have a quick break, yeah? Let's pause here, have a quick break. Okay, so we established that Q is the vertical shift, okay? P, we already mentioned a while back. What is P? Horizontal. It's the horizontal shift, okay? The whole business, if it's positive, it's shift to the left, it's negative to the right. Come, Jojo, we started, okay? A is about how steep it is. Come on, Jojo. Okay? A is how steep it is, but it's also the orientation. If it's positive, it's going to be like that. If it's negative, it's going to be that way. So we can actually tell us right now that A is negative. You're right. We know that A is negative. But before we get to A, which to be able to know what the number is, we tell you now already, we need to do substitution. Let's figure out P and Q straight away. Now by looking, I'm not going to say, you can see these numbers in red. What is P and Q?
Q is minus 1.
P would be plus 1.
Let's start with Q. Q is the easy one. What is Q? It's plus 1. Okay? You can see that this horizontal asymptote moved by 1. So Q is 1. What is P?
Plus 1.
P is plus 1 because the vertical shift moved 1 to the left. Okay, meaning P is going to be positive. And the only thing we still need to know is what A is. Okay, we guess that it's going to be negative. But to know it, we need to substitute, yeah? We need to actually get a number, right? So what x and y can I substitute? Okay? Great. So as I told you, to solve these things, it's like you need to solve a mystery. And you get clues. What are the clues? That's one clue that help us find the Q. That's one clue that help us find the P. These two clues, or it's just one clue really, help us find the A. So when X is 2, Y will be equal to 5. You're right.
69.
You're right. Yeah. Yes, and it was minus 2. Because it's on the left side. Thank you. Okay? Alright, are we happy with that? Okay, but you understand what I've done here?
Yes.
Okay, then we rewrite it and say 5 minus 2 plus 1 is minus 1, so it's minus A plus 1. I would put the A to this side, put the 5 to the other side, I get A equal minus 4. Okay? And then, okay, I'll just leave it like that, write it again, don't be lazy. Y equal minus 4 over X plus 1 plus 1. That will be my function. I'll just pause here. To finalize the hyperbola section, I need to again, like we did for a parabola, mention domain range. Okay? And domain and range, if you remember, the domain is basically where all the x's live. Okay? It's all the possible x that you can fit in this function. Okay? And the range is like in a shooting range, is where you're shooting up to is the y. Okay? We've got a function that takes an x and assign a y to it. So let's start with the domain. Can I use any x in the world here?
No.
We can either look at the function or at the graph. That question can come in either way. You're right, there's one x that is problematic. What x is we're not happy with? Negative 1. So I'm just going to pause here. Okay, so as you guys said, the only option, the only problem is x equal minus 1. We can't put minus 1. You can see because that's the vertical asymptote. We're never going to have an x minus 1. You can look at it also in the function. Okay, I might not give you the graph. I might give you this function. You can see that there's going to be a disaster if we put x equal minus 1. Okay, because then it's undefined. So what in terms of exam requirement, you need to say x not equal to 1 minus 1, but x belong to R. So it's both of these things. So in other words, you can take any real number except for minus 1. Okay? Right. Now what about y? Now, yes. The best way to do it is if you have the graph. Is there a y that is not getting covered here?
Yes.
Which y is not getting covered? Correct. So I can look at any y, let's say minus 2. I will find a y somewhere on the graph that has y minus 2. I can go to y equal minus 1,000. That graph carries on, yeah? I'll find y with minus 1,000. I can do y equal 15. It's going to be somewhere here. But there's one y that you'll never see in the graph, and that is y equal 1. So I'm going to say y is not equal to 1, but other than that, y belong to the real numbers. Okay? Alright, I'll pause here for a second. Okay, this is it. I'll say goodbye, and we're going to carry on working in class. Bye-bye.